Hi. So this is special right triangles is what we're talking about today. And this is probably going to be the longest video because I want to show you, I have the formulas, but I want to show you why the formulas are the way they are. Okay. So we're going to do a little bit of discovery, not exactly to the extent of we would have done in class, but if you see here, let me go to my document camera here. Alright, so you see here I have a square. Okay, squares, we talked about squares. You did squares in the last chapter. Squares have all equal sides and all right angles. Okay, so since this side is 18, this side is 18, and this side is 18, and this side is 18. 18, 18, 18. All the angles are right angles. Okay, so we're talking about triangles, of course, not squares. So to make this a triangle, I draw a diagonal. Okay, now, one of the rules of a square is that the diagonal bisects the angles. That's a rhombus rule. The diagonal bisects the angles, and the square is a rhombus because the square has equal sides. Okay, so since this 90-degree angle is bisected, this is now 45 degrees. And this is now 45 degrees. And if we need to find the third side, we do the Pythagorean theorem. And I called it C because it's a hypotenuse on this right triangle, and the hypotenuse is C in the Pythagorean theorem. If you watched the Pythagorean theorem video already, you've learned that. Okay, so when I set up the Pythagorean theorem, these two are A and B. So I have 18 squared plus 18 squared equals C squared. Okay, 18 squared is 324 plus 324 so that's, oh my gosh, I could have done that in my head. Okay, equals C squared. Okay, so then we need to square root both sides to get just C. 648, do this off to the side, 648. Well, I know that's 324 times 2. And 324, I know, is 18 times 18. And yeah, I can break the 18s down into 9 and 2 and then 3 and 3, but I'm not going to do that because I already have twins. So if I break out my twins, that's 18, and I have this 2 left behind. So I have C equals 18 that broke out, and then the radical 2 left behind. Well, what's the relationship there? The sides, let's say that's 18 radical 2. Okay. The side is 18, this side is 18, but the diagonal is 18 radical 2. It's the same as the side with the radical 2. And that's actually how we come up with the formula. It doesn't matter what I used for the length of the side. If this was 20, that would be 20 radical 2. If this was 16, that would be 16 radical 2. If this was 512 and this was 512, that would be 512 radical 2. Okay, so, because there's a formula. And if we were in class, you guys all would have had different numbers and done this, and all discovered that you all got the same length as your side with the radical 2. So the formula, and this is, you notice the angles are 45 and 45 and 90. That's 45, 45, 90 triangle. It's called a special right triangle because it has a special formula. Because for every 45, 45, 90 triangle, the hypotenuse is always whatever the leg is times square root of 2. And the two legs are always equal because remember this is half of a square. So those two sides are equal and we have the 90-degree angle. The hypotenuse is the leg times radical 2. And that's how we discovered the formula for this. Like, this happens enough, you can make a formula for it. So we made a formula for it. Okay. Now on to the other part. Equilateral triangle. Equilateral triangle has 3 equal sides. 1, 2, 3. Equilateral means equal sides. So all 3 sides are 18. It also has 3 equal angles. So if you have 180 degrees and you split it up 3 ways, each angle is going to be 60 degrees. Okay, and that is a triangle, but if you notice, there's special right triangles, right, and there's no right angle here. That's 60 degrees, 60 degrees, 60 degrees. So what we do is we draw an altitude. If you've watched the geometric mean video, then you would know that this line right here is called an altitude. Altitude. Okay, that's the altitude. An altitude is a perpendicular line to the base. Okay, so that's what this line is. An altitude is perpendicular to the base. One thing an altitude does on, let's work on this side. One thing an altitude does on an equilateral triangle is it splits up this angle into 2 equal angles, which means this is 30 degrees and this is 90 degrees. So this is called a 30, 60, 90 degree triangle. Since all the sides are equal, I know the side is 18. The altitude not only splits this angle up into 2 equal parts, but it splits the base up into 2 equal parts. So if the base is 18, because it's equilateral, all 3 sides are equal, then this part of the base is 9. Okay, and then to find this part of the base, I was going to call it b for, a squared plus b squared, but I don't want you to get confused on it being like not the base. It's an altitude, so I'll give it an a for altitude. How's that? Also because it's either a or b, so that works. Okay, so when I set up the Pythagorean theorem for this 30, 60, 90 triangle, remember that C is always the hypotenuse. The right angle points to the hypotenuse, and if you've seen the Pythagorean theorem video, you would know that. Right angle points to the hypotenuse. So 18 goes in the C spot, and then the other 2 go in the other 2 spots. Okay. 9 squared plus a squared equals 18. I could write a squared plus 9 squared equals 18 squared also, either way. So I know this is 81. I know this is 324. So 324, I need to minus 81 from it. 324 minus 81 is 243. So we're subtracting 81. And so I get a squared equals 243. And this is not a perfect square. So when I square root both sides, we need to do the square root of 243, which means breaking it down. I know 3 goes into 24 and 3 goes into 3, so I'm just going to reduce this by 3. Okay, 3 goes into 24 8 times, and 3 goes into 3 1 time. And 81 is easy because that's 9 and 9. And now I have twins. Remember, twins break out. Now I could break the 9s down to 2 pairs of 3s and then break out 2 pairs of 3s. It's just easier if I already have twins, they can break out. So I get a equals 9 that breaks out. The radical 3 is left behind. So if you notice, a being 9 radical 3, this leg here is the same as this part of the base. So whatever your hypotenuse is, half of that is with the radical 3 for that. So there's a pattern there, and if we had done this in class, everybody would have gotten a different number, but everybody would have gotten that this is half of that, and that this, that this one is the same with the radical 3. Okay. So the formula. Notice the angles are 30, 60, and 90. It's called a 30, 60, 90 triangle. Okay. 30, 60, 90. Here, it's important to know what the sides are because the sides have special meaning. So if you know where the 30-degree angle is, then opposite that is the shortest leg, which we actually did that before in chapter 7 in March. You know, the smallest side is opposite the smallest angle, and the largest side is opposite the largest angle, that kind of thing. Hypotenuse is always the hypotenuse, but of the two legs on this one of them's bigger and one of them's smaller. On this one, they're both equal. So we don't have a long leg and a short leg because they're the same. But on this one, the angles are not equal, which means we're going to have a big side and a long side. We call them legs because the hypotenuse is always the biggest. Okay? So opposite the 30-degree angle is called the short leg, and opposite the 60-degree angle is called the long leg. Okay? Now the hypotenuse is whatever the short leg is times 2, and the long leg is whatever the short leg is times radical 3. So our short leg here was 9, the long leg was 9 radical 3, and the hypotenuse was 9 times 2, which is 18. So whatever your picture has, use the formulas that go with it. Okay. So when we get to example 1, let me readjust here. And there's a lot of examples on this one. I'm really sorry. This is going to be the longest video. So, I mean, you could always play and pause it and play it as you need it, going through the lesson, because it does take a while. You know, maybe take note of the time of everything so you can know when to play, like where to play it from, where you left off or something. Okay. So identify your triangle first. This has a 45-degree angle and a 90-degree angle. So obviously, it's not going to be 30, 60, 90. That doesn't have a 45-degree angle. This has a 45-degree angle. We're going to use these two formulas. It helps identify the sides. So we have a leg here. No, that's not a leg. That is opposite the right angle. Opposite the right angle is never a leg. The right angle points to the hypotenuse. This is going to be called the hypotenuse. The other two sides are called legs. And since it's a 45, 45, 90-degree triangle, I mean, this 45 isn't written, but remember they have to add to 180. This has to be 45. Okay? The legs are equal. We don't have a long leg and a short leg. They're the same. So whatever 9 is a leg, that means X is a leg. So that's easy. X equals 9. X is done. Y. Y is the hypotenuse. So we use the hypotenuse formula. Hypotenuse equals leg times radical 2. Whatever your leg is, plug it in. Our leg is 9. So 9 times radical 2. Oh, hypotenuse is y. So I could just call it y rather than hypotenuse. Okay, so hypotenuse, we could plug in the y in the hypotenuse spot, equals leg is 9, then radical 2. Okay. And then we solve 9 times radical 2, so y equals 9 radical 2. We can't actually multiply them. So we write them basically next to each other. So for the next picture, identify the type of triangle. The type of triangle, well, it has a 30-degree angle. Only one of the two triangles have a 30-degree angle. 30, 60, 90. Okay, that 30-degree angle, if you draw an arrow away from it, that would be your short leg. SH for short. Okay. The right angle points to the hypotenuse, so this is our hypotenuse. And then we have X is the long leg. Okay, you want to make sure you identify those. Now that you have that, you can use your two formulas. So our formulas, hypotenuse equals short leg times 2. Let me write it down. So let's look. Our hypotenuse is actually called y. So let's just replace that with a y. Love these pens. Okay. So hypotenuse gets replaced with a y. The short leg, so let's look. I've labeled that. The short leg is 5. So I get y equals 5 times 2 is 10, and now I found y. I don't have to find x first if I don't want to. Okay. So the next formula. Okay, sorry about that. Here we have long leg equals short leg radical 3. The long leg here is x. The short leg, in the short leg spot I put a 5. So I plug it in. I get x equals 5 times radical 3. I can't multiply them, so I write them next to each other. There we go. We're not done. I know this is the end of the page, but I actually have another page. There's a lot of examples on this one. I'm going to keep this paper handy for notes. Okay, so let me readjust my document camera, and I'll try to go faster. So I don't want this video to take an hour. Okay. So example 3. Here we have a 60-degree angle. So obviously that is a 30, 60, 90-degree triangle. So the right angle points to the hypotenuse. Okay. If this is 90, this is 60, that makes this 30. And that goes to the short leg. And that means the other side is the long leg. Okay. So we use our formulas. So if I wanted to use my long leg formula, okay, so it is long leg equals short leg times radical 3. Well, my long leg is x, my short leg is y. Well, that has two variables. I can't solve something that has two variables. So that means we have to use the other equation. So the hypotenuse. Okay, so the hypotenuse equals the short leg times 2. Hypotenuse is 10. My short leg is called y. So now I have 10 equals y times 2, which I could rewrite that. We usually put the number in front of the variable, like that. And then we would divide both sides by 10. 2, sorry. Brain's not working. I think I was distracted by my phone call. Okay. So it's 2 times y, so we divide by 2. So I get 5 equals y. Now that I know 5 equals y, I can come over here and replace y with 5. And then I get x equals 5 radical 3. Okay. Notice I had to find y before finding x, and that happens a lot on the assignment. Always make sure that you put things in the right spot. So if you find y first, make sure to put it in the y spot and not the x spot. Okay? So even though you find y first on a lot of problems, you have to input it in the right place. Okay. Example 4. Notice we have two equal sides, 6 radical 2 and 6 radical 2. Well, there's only one kind of triangle that has two equal sides. Well, since that's a long, a short, and a hypotenuse, that's not two equal sides. So this one, we have two legs that are equal. Leg equals leg. So our hypotenuse equals leg times radical 2. Plug it in. Just a second. This is our hypotenuse, leg, and leg. We already know the legs are equal. So it's hypotenuse, x, equals leg times radical 2. Whatever your leg is, times radical 2. Even though our leg already has a radical 2, we still have to multiply it by radical 2. So we get x equals 6 times radical 4. And I hope you know what the square root of 4 is. So x equals 12. Okay. Next problem. Has a 45-degree angle, which means 45, 45, 90 triangle, which means the legs are equal. X equals y. But x equals y is not an equation that will give us any answers, because you'll get the wrong answer. So we'll have to fix that. So we need the hypotenuse formula. So hypotenuse, let me use a different color. Hypotenuse is 8 equals, it's hypotenuse. The leg, I'll go with x because I like finding x first, times radical 2. We cannot multiply x times radical 2. So that means we divide by radical 2. If you remember first semester at all, you learned that we cannot divide by a radical 2. We're never allowed to have a radical in the denominator, so we multiply it. Radical 2 over radical 2. Mrs. Cortez and I taught you a trick. You move the radical upstairs and it becomes whole downstairs. Okay? But 8 radical 2 over 2, 8 over 2, those are both whole numbers. They can be reduced. And if a whole number can be reduced, you always reduce it. So I get x equals 8 divided by 2 is 4 radical 2. Okay? Since x equals y, that means y equals 4 radical 2, because they have to be the same thing. Okay? So remember, the hypotenuse is pointed to by the right angle, and the other two sides are the same. Okay, this one, I think I forgot to put a bit of information on there. That's important. I don't know why I forgot that. That was my bad. This is the question now. Okay. So the right angle points to the hypotenuse. This one, it is very important you label the sides. The 30-degree angle points to the short leg, and then the long leg is on the other side. Okay. If I use the hypotenuse formula first, short leg times 2, sorry. Short leg is y, hypotenuse is x. So hypotenuse formula. X equals y times 2, that's two variables, we can't do that. So we have to use the long leg formula. So that's the long leg, which is 12, equals the short leg times radical 3. So since we can't times y and radical 3, we need to get y alone. We would divide by radical 3. So this is similar to the last problem. So we get y equals 12 over radical 3. And since you can't have a radical in the denominator, top and bottom. So you get 12 radical 3 over a whole 3. So the radical moves upstairs, becomes whole downstairs. But 12 and 3, they can reduce. The radical 3 can't reduce by 3 because this is a radical and this is whole, and you can't reduce a radical with a whole. So we get 4 radical 3 as y. I had to find y first. Make sure to put that in the y box when you answer the question. If you find y first, put it in the correct spot. Okay, then I have my question here, x equals y radical times 2. So x equals, y is 4 radical 3 times 2. Well, 4 and 2 are both whole numbers. So x equals 8 radical 3. Okay, I have one more problem. A little bit more critical thinking on this. It says, what is the length of the altitude of an equilateral triangle with side length of 4 radical 2? Okay, equilateral triangle. I started out my lesson with an equilateral triangle. Well, I mean, not the start, because I started with a square. But right after that, I talked about an equilateral triangle. I also talked about an altitude, okay? So it helps, in this case, to draw a picture. So my picture is going to be of an equilateral triangle. The side length is 4 radical 2. It also talks about the altitude. We have altitude here. And remember, the altitude is perpendicular to the base. And remember that the angles are 60. But this one gets split and becomes 30. And remember that this part of the base is half of the whole side. So if the whole side is 4 radical 2, half of 4 is 2 radical 2. And then it says, what is the length of the altitude? So we need to find that. So this is the hypotenuse. The 30-degree angle points that way. So this is the short leg, which means x is the long leg. So we're going to use the long leg formula. So the long leg equals the short leg times radical 3. Okay. I don't know if my screensaver popped up again, but it did it in Pythagorean theorem video too. I don't know why it does that. So x equals 2. And then, since these are both radical, you can multiply them. Radical 2 times radical 3 is 8 radical 6. Okay. That's how to find the altitude of an equilateral triangle. Okay, so remember the rules for an equilateral triangle, because that comes up multiple times, and you'll get it next year also a lot. So this is the end of the video now. That was the last problem. So I hope you have a good week and get your assignments done. You will have a test. This is all the test is on. The 3 videos that you saw this week are the 3 topics that are going to be on your next test. So have a good day.